Welcome, ladies and gentlemen. Thank you for subscribing to this online event. I'm very excited to giving a short presentation about development of bearing suppliers and quality control during purchasing. I would like to start with a brief introduction about our company, about myself, and then we have 5 main questions that shall be discussed today, which are the motivation, special measures referring to the pandemic concerning supplier quality control. We will talk about quality levels, differences in load rating, and further remarks before I finally going to conclude everything. Yeah, about our company, Elgeti Engineering has been founded in November 2009, so it's more than 11 years old now. We are a team of 12 people located on 2 continents. We have our headquarters in Aachen, Germany, and we have a branch in Valparaiso, Indiana, in the USA. And the 3 people you can see here are your main contact persons. This is myself. And then we have the 2 branch managers for our 2 sites. And about our company, what are we doing? The main activities of ours are related to third-party failure analysis of machinery, not limited to bearings, definitely anything that turns predominantly gearboxes in very, very different applications, from automotive to wind energy and everything in between. And the second big topic is bearing supplier development based on audits, on-site inspections of the factories, and testing. Testing is our very strong point. We develop and produce bearing test strips mostly for our own laboratory, but also for customers. And apart from that, as we consider ourselves still as a consulting company, our mission is sharing our knowledge, and this is what we do on a regular basis by online trainings, online seminars, and there is, by the way, there is a topic or there is a complex of seminars with the same topic, with the same major topic, but certainly will go further into details. So let's talk about the motivation, and I would like to gather your attention to each of the chapter just by asking a simple question, and starting with the sentence, never change your winning team. Why actually is supplier development necessary? I think this was also one of the questions that had been shared by Bearing News in advance. So yeah, why is supplier development necessary? First of all, the question is your team really winning? That's the first question. Nevertheless, the predominant motivation for approving new suppliers is definitively cost reduction, cost reduction, cost reduction. This is what you see everywhere. Everyone who buys bearings or who buys parts, semi-finished parts, buys components for the equipment is in competition. And if your competitor offers similar products, similar services for significantly less prices, then you have to justify, and you can take this competition by certainly taking care for your own cost structure, and this can possibly go along with a new new suppliers. Next big topic is reduced delivery time. Sometimes, especially concerning big size bearings, delivery time can be really relevant, and can be absolutely critical. Sometimes we face delivery time or lead times of more than 12 months, which is basically impossible. If you have a damaged machine, you need a spare parts, or if you want to build something and all your assembly line is just stopped because you don't get the sourced parts delivered, then you need an alternative solution. And you should in best case take care for this solution as early as possible before you have a problem, because a proper supplier approval takes some time, and you shall be prepared before the problem appears, in order to have your backup solution, your plan B, available, and don't need to prepare this. This is basically what we see currently when we look at our governments, who want to solve the pandemic. You can see what happens if you're not prepared, and if you don't have a plan B if something doesn't work. And I think the results talk for themselves. Increased flexibility is highly important. This means, for example, if you are, as a customer, too relevant, for your supplier, which could happen if you, for example, if you buy, let's say, 50 or 60% of their regular production, and your own production volume changes. Then the question is, can your supplier follow? Can your supplier follow the varying demand? One situation could be, you suddenly make excellent excellent sales. You can sell double or even 3 times more as expected. It can even happen due to some political changes. If you think about battery electric driven vehicles, which had been supported by our federal government in Germany recently quite a lot, and accordingly now their lead time just went up dramatically. But this applies to all your supply chain, and if then your supplier just cannot follow because they don't have the capacities, then you need other solutions. It's the worst thing that can happen is that your customers want to give you their money and you just can't deliver because your suppliers can't follow. This is one problem, one possible problem, and the other way could be problematic as well. If you have, for whatsoever reason, a temporary drop in sales, and this means also you have a drop in purchasing, this could, in worst case scenario, lead to your supplier going bankrupt. And if when production starts again, then you don't have a supplier anymore. So you need to handle your supplier base in a way that you can be prepared for everything that can happen. Being flexible as you have to be for your customers, your supplier base has to follow, and maybe one particular supplier cannot, but they can be still be good suppliers. Then you need several of them. Increase quality. Yes, maybe you overdid cost reduction in the past, and you see that apparently your current suppliers don't provide the quality you need. Then you need to take action, and then you need to find other solutions. Obviously, I think that doesn't need to be explained more. And which can be quite interesting is introduction of special solutions. If you think about wheel hub bearings for passenger cars, some decades ago, these had been just regular standard catalog bearings. And nowadays we have them integrated into a hub with 2 flanges, and even more, the speed sensor for the anti-blocking system is even integrated in the wheel hub bearings. This is a special solution where functions are integrated. This, unless you are working in automotive industry, is not possible with mass production. This means integrating further functions can make sense at many different occasions. But if you source from mass production, they will be, unless you request by yourself mass production, like automotive industry, your supplier would be very unlikely to do that. But if you would work together with a company that has a similar size like you, they might possibly be much more flexible. And then you can achieve very smart solutions, very smart designs, which can be the special unique cells argument. Apart from that, risk reduction. They say never put all your eggs in one basket. And we can have, for whatsoever reasons, we can have delivery problems of one supplier, or we can have quality problems of one supplier, which means if they have a problem, they possibly need to take time for solving everything, but you still need your parts. Currency exchange rates, political influences, a war, a coup, a revolution, all these things can happen. And apart from that, certainly a pandemic can happen, which doesn't allow for international traveling, which will have impact on all your supply chains. And for such situations, you need other solutions, you need other options, and this means you shall not be dependent on only one supplier for each particular part. So supplier quality control during the pandemic. Typically supplier quality control involves repeating audits and factory visits, which in many cases are currently not possible due to the pandemic. And the question is, what can we do instead in order to keep our quality control level? And here I would like to refer to our standard recommendation, according to our seminar on the same topic. And here you can see how a quality concept could look like. It has the three main items, which are supplier control, first sample inspection, and incoming inspection, and the regular supplier control for standard quality bearings. If you are sensitive for quality, means that prior to any approval, you shall visit them, and then you shall once per year, more or less, audit them by a qualified auditor. And certainly this concept can be adapted to particular requirements, but this is more or less what it is about. And here with the yellow marking, you can see that there are two methods that are currently possibly in many cases just not possible. So if we are located here in Germany, and if we source from China, for example, it's just not possible right now to just to book a business trip and just to visit our suppliers in China. And in many other countries, it's the same. As well as Europeans, we currently cannot enter the United States of America, for example, and there are many more travel restrictions, strict restrictions. But apart from that, even if there are no restrictions, you're currently not supposed to put it that way. Even if you're allowed to, you're not supposed to. As we all know, pandemic spreads by contacts, and you better stay safe, stay at home. So, nevertheless, if your quality concept is based on these methods, you need to find, and you can do this. You shall not open the door for any quality issues. You need to have an alternative concept. You need to have alternative method. And you can maybe partially compensate this here with the other methods, especially with the incoming inspection. And especially concerning incoming inspection, I just would like to introduce the method of rapid testing. Rapid testing of bearings, endurance testing. Among all the testing strategies, which can refer to, let's say, verification of expected performance, or to A to B comparison of two different suppliers. This is quick and easy, quick and dirty. Not really dirty, but quick and therefore affordable, and that's the important point. It is likely to detect major flaws, which means if you have a bearing test strip like this, and you do not need necessarily to have it yourself, you can concern a laboratory for this that has one. You can, for example, take 4 samples out of a shipment, which can apply either to incoming inspection or to first article inspection, and apply really tough conditions, resulting in theoretic life expectation of 50 hours, 60 hours, something like this, with a suspension criterion of 2 times this theoretic value, which means 100 to 120 hours, less than 5 days, obviously. And your approval condition would be if there would be no failure among 4 samples within 2 times theoretic life expectation, then obviously there shall not be any major flaw. This is definitively insufficient for a total, let's say, supplier approval, but it is something that can help you detect things. It can help you for detection of grinding burns, for hardening cracks, if there would be the wrong material, even if the outer dimensions would be wrong, you would not be able to mount these bearings in your test rig. And so it can basically replace all the other inspection. And apart from that, and I think this is highly important, it provides added value, added information, because if you do any kind of whatsoever incoming inspection, geometrical inspection, metallurgical inspection, etc., this is what your supplier should have been done before as outgoing inspection, and or regular production inspection, production quality control. And so you just confirm data which does already exist. If you conduct a test run instead, then this is some kind of integral approach. Yeah, you do know if it fails, you don't know why at the first moment. You can then trigger further inspections. But you know, if these survive, then everything shall be fine. And I would like to just to compare this a little bit with a marathon competition. Yeah, if you want to participate, you normally shall give a certificate from your doctor that you are healthy. Yeah? And still on each, let's say, big marathon event, yeah, with 20,000, 30,000 starters, there are a couple of them that just collapse and die on the track. It happens, unfortunately. Yeah, and despite the fact that they got a certificate from a doctor to be healthy, yeah, but the point is, and this is like all the quality inspections, the doctor does not conclude that you're healthy. What the doctor concludes is that with the inspections conducted, there was no positive finding. Now everything was within tolerance. And the same applies to your bearing quality control. If you check the dimensions, if you check the material, etc., then you can conclude everything is in tolerance, and therefore you assume that things shall be okay, but you're not, don't have this final proof. On the other hand, if you do the integral test, do a test run, like the marathon runner, if they finish, if these 42.195 kilometers, they could impossibly have been that ill. And that's the idea behind this. If there would be no failure, then it can't be the worst part. The shipment should have to be okay. So quality levels. Bearings are offered in various quality levels in the market, especially in trading business. And the question is, how can I decide which quality is suited to my application? And just for supporting this expression quality level a little bit, there are different understandings of this. Some people think about bearing quality levels. They think about particular brands. I don't want to mention their names here, but I think everyone knows whom I'm talking about. Which are supposed to be premium brands, etc. While some companies themselves, some factories, they offer A level, B level, C level, etc. And especially in bearing trading business, and there the worst things happen, unfortunately. In bearing trading business, you will find companies that offer 5, 6, 7 different performance levels, with different prices, different brands on them, but all delivered by the same manufacturer, not the same distributor, sourced by different factories. And the question is, what is this about? And at the end of the day, you need to decide. And sometimes people do it that way. Okay, I have a very challenging application. I need only the best of the best. I will take this particular brand, and nothing else. Full stop. And others say, okay, we can still consider other ones, which are also quite famous with a good reputation. And sometimes they say, I don't have that high requirements, don't have that high loads. We can take something easier, put it that way. And then there's the other extreme, for example, like the wheels of the shopping cart in your supermarket, that nobody takes care for the quality at all. But this would be the extreme case. But in the first three, between the first three options, there is plenty of room for optimization, and I would like to bring a little bit of light into this topic. And in this context, I would firstly would like to define what is a standard quality. And you can consider a premium quality as something superior. You can define something like almost standard, whatever you like. But before talking about this, let's first define what would standard quality, what would it mean? And according to my understanding, and just by the way, standard quality, the expression itself is not does not come from any standard. But my personal understanding is load rating can be calculated based on geometry according to ISO 76 and ISO 281, for example, or equivalent. And this means the dimensioning and lifetime prediction of a particular bearing arrangement can be done according to these standards. If you do your lifetime calculation and you conclude 5,647 hours lifetime, this shall be true. You must be able to rely on that. On that. That's standard quality. And this is traced back to, and so these are the premises of the standards: hardness of minimum 58 Rockwell C, material cleanliness according to ISO 683 part 17, fine grinding of raceways, no super finishing. And this is just a first remark. For example, this explains why we have something like a premium quality, or something superior than standard quality. Actually, when the standard has been published, super finishing itself did already exist, but was not the general standard out in production technology. Nowadays, especially for small size bearing, almost everyone does so. But still, the standards don't request this. Even without, your lifetime calculation can be valid. And this means with super finishing, especially in mixed friction conditions, your bearings might possibly outperform the theoretic lifetime. And production methods according to state of the art from approximately 1990. These things are, say, the first two ones are directly mentioned in the standards. The other ones are this is their general non-written assumptions, referring to the time in which the standard had been written. So, and this means any deviations from your standard quality level, if you think about, I don't need that much standard, or just a little bit less, could be fine if it's cheaper, or I need to have something better. This means any deviations in either direction have to be traced back to measurable properties and result in adapted design methods. Measurable properties, for example, better materials, higher hardness, super finishing, etc., but also design methods. The point is, if you calculate your bearing life according to ISO 281 with a certain safety in everything what you're doing, standard quality would be exactly what you need. Premium quality, which is superior, which is outperforming this, would be nice to have, but you don't need it. And this is your room for optimization. But the details of this would be too much for this presentation. Differences in load rating. Next topic. Sometimes we can find highly different load ratings for bearings of the same type made by different factories. So how shall we handle this? And the question is, what are the reasons for these differences? Well, load rating can be calculated according to ISO 76 and ISO 281 only based on the geometry, especially using the following data: rolling element diameter, number of rolling elements, effective length of rollers, pitch diameter, pressure angle, etc. And certainly the related formula refer to the assumptions as mentioned before for the standard quality. And the design can be different. The internal design of the bearings can be different. Accordingly, the load rating can be different. If you think about deep groove ball bearing, sometimes people make this with 8 balls. The same others use 9 balls, while ball diameter would be slightly less. There is no right or wrong. The more rolling elements, just in general, will lead to much smoother behavior, less vibration emissions. While on the other hand, if you only have few rolling elements, the bearing would become less sensitive for particles, less sensitive for cylindricity deviations of the surrounding parts, etc. So there is always a compromise between these two, and therefore there is no right or wrong, and this can lead to slightly different load rating, especially and also cage design. Sometimes, if you think about roller bearings, cylindrical roller bearings, sometimes a cage just provides the space for one further roller, and this will lead to accordingly higher load rating. Alternatively, you can trace back your load rating to testing. This is also possible, as your load rating basically is a promise on performance. And therefore, some manufacturers just apply additional factor, and promise you 5% more or 10% more or whatsoever. Yes, and if they can justify this by testing, this is totally fine. Apart from that, some manufacturers just copy catalogs, without having equivalent design. Or what I did also see some people is they just take 95% of competitor data and that's it, and they just don't think about it. And therefore, my recommendation is always verify load rating based on the ISO formula. Then you can identify any political influences. If you want to compare different suppliers, it is essential to compare them based on the same gauge. Further remarks, so standard bearings made by different manufacturers can be easily interchanged due to standard outer dimensions. That sounds simple. And the question is, are there further points to be considered in order to avoid unexpected problems? And I think this is the most important question of this presentation. And therefore I put it to the end. So I just would like to give you 5 points to think about. Cages, for example. This used to be a cage of a cylindrical roller bearing in railway application, and sometimes particular cage properties may be essential. This cage did replace another one, which was again a solid brass cage, but slightly different in design. And these tiny differences made one cage stand and another one fail. And so it can be these things, and therefore be careful if you change things. Materials, sometimes we have case hardened bearings, sometimes through hardening. There are applications, especially when you face excessive shocks, where it can make a difference. If you just order a standard bearing according to standards, both is fine. The supplier can choose whatever suits to them better, and therefore, but you might possibly be sensitive without knowing it. Interchangeability of rings is highly important. If you think about tapered roller bearings or cylindrical roller bearings, then typically it's possible to take one ring off the bearing of the other ring together with the rollers, and you can mix them up. It's possible, but you're not supposed to do this normally, because the standard bearing dimensions. For example, for tapered roller bearing, we're talking about the stack height, or for cylindrical roller bearing, we're talking about the radial clearance. These refer to one complete bearing. There's no directly resulting tolerance for one particular ring itself. And this is what your supplier has to deliver. But sometimes it's nice, if you install a gearbox or in a production line, have one half assembly line where you put all the inner rings on the on the shafts, and you have another half line where you put the outer rings in the housings, and then you marry them to each other. This can be very nice, but um, um, uh, so with a different supply, this might possibly not be good, just because the dimensions might change, and this is something to do with production methods, and needs special attention, and needs to be verified in particular. Number of rolling elements, few large or many small ones, both can be fine. There is no right and wrong, but possibly you are sensitive in your application. And finally, thrust load capability of radial bearings, for example, deep groove ball bearings. Again, there is no standard for this. There's even no standard for the thrust load capacity of cylindrical roller bearings. If you think about NUP or NJ bearings, but maybe in your application they need something. And what I would like to say with that, there are many details that can result in some optimized design for cost point of view that can be a problem in your application. So if you want to approve a new supplier, be careful, and in case of doubt, you shall assume that there might be something else to be considered. I would like to summarize this presentation. The reasons for supplier approval refer especially to costs, flexibility, quality, and risk management. Risk management is highly important, as these days show to everyone. Rapid testing can be a powerful alternative to audits during the pandemic, especially for small size bearings. The standard quality refers to standard calculation, both of load rating and also bearing life, bearing performance. But everything else, if you have different levels, must be traced back to measurable properties and also to design approaches. This is highly important. Otherwise, your design would be unsafe. The difference in load rating can be based on different internal design or politics, just for some sales strategies, and you shall verify therefore in best case, and lots of further details can be relevant and shall not be underestimated. I would like to thank you very much for your attention. It was a pleasure talking to you, and I look forward to hearing or reading your questions and to stay in touch. Take care, everyone. Stay safe, and I look forward to your feedback. Thank you very much. Bye-bye.